Good afternoon, everyone. Thank you so much for joining us today. My name is Emily Silva, and I'm the NECAN coordinator. I'd like to welcome you to the 5th webinar in the NECAN Student and Early Career Scientist series, in which we've been highlighting the work of students, PhD candidates, and early career scientists who are working on ocean and coastal acidification. The full schedule, along with past webinar recordings, can be found on the NECAN website, necan.org/student webinars, and announcements are made through our newsletter, so make sure you're signed up for that. A link to do so can be found right on the bottom of our homepage of necan.org. Throughout the presentation, if you have any questions, you can submit them through the questions tab on your GoToWebinar control panel, and we'll go through each of them during the Q&A session following the presentation. And if you'd like, just indicate whether your question is for Parker or Jennie or for either of them. Today we'll be hearing from Jennie Rheuban from Woods Hole Oceanographic Institution and Woods Hole Sea Grant, and Parker Gassett of the University of Maine, Maine Sea Grant, on expanding OA monitoring capacity with community science. Jennie's a research specialist in the Marine Chemistry and Geochemistry Department at the Woods Hole Oceanographic Institution and research coordinator for Woods Hole Sea Grant. She received undergraduate and graduate degrees from the University of Virginia prior to working at WHOI. She's a coastal biogeochemist whose work focuses on anthropogenic impacts to our coastal ecosystems and natural resources, specifically studying coastal carbonate and nutrient chemistry, as well as aspects of climate change. She became involved in Shell Day first as an invited participant to one of the NECAN monitoring workshops held at MIT, then as a science and logistical coordinator for the Southeastern Massachusetts for the actual pilot sampling event. Parker Gassett earned a degree in environmental biology from Beloit College in 2011, and in 2016 began his PhD research on local management opportunities for ocean acidification. Parker now works for the Maine Sea Grant program at the University of Maine as the Community Climate Resilience Coordinator. Parker's also on the NECAN steering committee, and he's a co-chair of the Education and Outreach Working Group and was a key part of the planning, logistics, and outreach for Shell Day. So with that, I'll hand things over to Jennie and Parker, and they can take you through their presentation.
Okay, Emily and or Parker, can you confirm to me that you are seeing my screen?
Yes.
Yeah.
Okay, fantastic. So welcome everyone. It's really exciting to have you all here today to share with you about Shell Day. I'm here, as Emily mentioned, with Parker Gassett, and we're here to talk about Shell Day, which was an effort to expand ocean acidification monitoring capacity with community science. So today we're going to really be focusing on sort of three main portions of this webinar. We're going to talk about a lot of outreach and engagement efforts that were really coordinated by NECAN and occurred over the course of several years prior to the Shell Day pilot sampling event. We're going to talk a little bit about the training efforts that happened as part of that outreach and sort of the design of the Shell Day pilot. Then we're going to share a little bit about the data that we collected on Shell Day and the sort of regional capacity for monitoring. And finally, end with some opportunities or potential opportunities and ideas for future sampling and engagement. So now I'm going to hand it over to Parker, who's going to kick off the rest of this webinar.
Thanks, Jennie. So there is a multi-year sequence to this work, but we're really going to focus today on a training and workshop series, the GIS resources that came from that work, and then the Shell Day event itself. And Jennie, if you'll click to that next one. So shown in blue are kind of the topics of today's webinar, and then in green are the resources that came out of the project, which towards the end of today's presentation we'll share with you, and in hopes that these are resources that others could actually use to conduct similar events. So starting in 2017, actually, yeah, we'll stay on this just for a moment longer. So a lot of this project was based on a unique opportunity with the Environmental Protection Agency. And they were working to put forward a set of guidelines for measuring ocean acidification in the Northeast US region. And so we oriented a lot of our work around community science as initially a way to share this new guidance from EPA, and also by sharing that guidance, learn more about the community science programs that were throughout the entire region. Now the next slide would be great, Jenny. So essentially, a common story is that we have just such limited data for the primary parameters of the carbonate system. There are so many information gaps along the eastern seaboard. And we know that very, very few institutions, or very few community science programs at least, are able to measure dissolved inorganic carbon, or PCO2. There are some programs measuring pH and some measuring total alkalinity, but for the most part, carbonate system monitoring is relatively limited, at least on the spatial scale of the NECAN region. And if you'll hit the next slide. But we also know that there is extensive monitoring for a series of other water quality parameters, which are ecologically related to the same processes that we're investigating when we think of coastal acidification especially. And we know that there are long-term, frequent measurements taken for chlorophyll, for nutrient information, oxygen concentration, salinity, and temperature, that the data sets in the NECAN region for these water quality parameters are abundant. And if you go to the next slide, we know that because of a series of workshops that we conducted in 2018. And in the picture that's on the bottom left, you'll actually see the two authors of the EPA guidelines for measuring ocean acidification in the Northeast US, Adam Pimenta and Jason Greer. And shown here are them demonstrating some aspects of the EPA guidelines. This happens to be a workshop in Massachusetts. And we conducted workshops in Connecticut, Massachusetts, and Maine, and really used this opportunity to find out what community science programs exist in the region, where are people conducting monitoring, what is their level of interest in ocean acidification, are they collecting information that's relevant to ocean acidification, and are they interested in adding this new environmental phenomenon as a part of the routine activities that they carry out. So if you go to the next slide, we found that a really high number of community science programs in the NECAN region, so from Long Island Sound to down East Maine, we're collecting these water quality parameters. Actually, a number of groups collecting pH, but very low numbers of organizations collecting total alkalinity, dissolved inorganic carbon, or PCO2. And we were very excited to see that the spatial coverage of these monitoring programs was extensive. And this really changed our understanding of the narrative around what OA monitoring is occurring in the Northeast region, highlighted by a story of data gaps and information gaps, to the potential of other community science water monitoring programs that are distributed across the entirety of the region. So if you go to the next slide, this felt immediately like an enormous network opportunity for NECAN, an opportunity to either incorporate OA parameters into existing community science monitoring programs, or the potential of coordinated regional monitoring. And Jenny, do you want to say how we got involved here?
Sure. So thanks, Parker, for that great summary of the events leading up to Shell Day. So as Parker mentioned, and shown in this map from let's see, previous slides, there was a really incredible amount of logistical effort, manpower, and financial resources that were identified that are really going into water monitoring across this region. That, as Parker mentioned, really represents an incredible opportunity to leverage this amount of unbelievable effort to expand some of these efforts into the OA monitoring space. And so we, after looking at this sheer amount of effort, really wanted to assess whether there were some really basic science goals that we could achieve by working with these community water monitoring groups to perhaps incorporate OA parameters into their efforts. And so that's sort of where Shell Day was born, as a pilot event that, as I mentioned, had several very basic science goals, of which the first was to really test a sampling protocol for community science organizations to collect carbon chemistry measurements. We weren't sure what the best way to do this was, what the best way to bring those samples back to laboratory facilities and have those samples be processed. So, the first goal was really to test how to do this well. This second basic science goal was really to determine whether or not we could develop a regional total alkalinity salinity relationship. Our sampling effort and sampling design really focused on total alkalinity mostly, as a sort of relatively straightforward carbon chemistry parameter to measure that's not sensitive to gas exchange and has a relatively sort of stable shelf life for a short period of time prior to fixing with mercuric chloride and making the samples shelf stable for longer periods of time. So we wanted to determine whether or not we could evaluate a regional relationship between total alkalinity and salinity, given that many of these water monitoring programs have been monitoring and already monitor for salinity across this region. And if we could develop a proxy relationship, that might help us to understand the carbon chemistry of this region. And finally, we wanted to evaluate the variability in total alkalinity across this region, both across multiple spatial scales and temporal scales. So looking both across the entire Northeast region, but also looking at within individual sampling station variability over a tidal cycle. Okay, so what did Shell Day look like? So the sort of regional coordination team worked with the community water monitoring organizations to train organizations and people who are collecting samples on the sampling protocol, provided cleaned and pre-labeled bottles for the water monitoring organizations to collect their samples. And on the Shell Day sampling event itself, participating programs collected samples across the tidal cycle. So at low tide, mid tide, and high tide on a single day across this entire region. We also asked groups to collect duplicate samples at low tide and high tide, which we used to assess the quality of the data that were coming in. Finally, after the samples were collected, they were stored on ice and transported to sort of regional science hubs, shown here in these little pentagons here. Those regional science hubs either provided immediate sample analysis if instrumentation was available on site, or preserved the samples and returned them to partnering laboratory facilities, which then samples were processed over the course of several weeks after Shell Day. So, okay, so what did this look like? Well, across this region, we had an incredible amount of participation from water monitoring organizations. So here on these two maps, you can see the coast of coastal Maine here and New Hampshire, as well as New Hampshire and Massachusetts, Rhode Island, Connecticut, New York. And there were 59 different organizations who helped us to collect samples on Shell Day. And samples were collected at 86 individual sampling stations across this region. So really an incredible amount of effort that went into the actual Shell Day sampling. From all of these sampling stations and the sampling across a tidal cycle, this represents 410 individual bottle samples that were collected across this region. Now, because there were duplicates collected at low tide and high tide, this ended up being 264 unique sampling events that were carried out over the course of this single day snapshot sampling. So really just, again, illustrating the amount of effort that can be coordinated together on this type of a distributed monitoring event. So what does some of the data look like? Well, we use those, as I mentioned, we use those duplicate samples to assess the quality of the data and the sampling protocol. And so here you're looking at histograms of the standard deviation between field duplicates collected at low tide and high tide and the coefficient of variation here. And what you can see is that the field duplicates agreed very well. The vast majority of those duplicate samples had agreed within less than 10 micromolar of each other, micromole per kilogram of each other. And with less than 0.5% deviation between the two samples. And so we were really very pleased with the quality of the samples that were returned to us when samples were then processed in the laboratory, partnering laboratory facilities. So as I mentioned, so in addition to testing this protocol, we wanted to look at variability and total alkalinity across this region. And so just to orient you to the graphics that you're looking at here, each of these map panels represents sort of a different region of the Northeast. Here you've got coastal Maine. Here's Maine, New Hampshire, and northern Massachusetts. This is mostly Cape Cod and the islands. And here is Rhode Island, Connecticut, New York here. On the right-hand side, so each of the sampling stations is identified by a number in the panel. On the right-hand side, in the sort of adjoining panels, are showing you a box plot of all of the data that were collected from that particular sampling station. So each of these box plots represents a unique sampling station, or the variability in total alkalinity at each sampling station. And roughly these box plots are organized going north to south across the region, although Cape Cod sort of goes around the Cape, around the Outer Cape, and through Nantucket, Vineyard Sound, Buzzards Bay, and then around the islands. But you can largely think about these box plots as going down the coast. And what you can see is that there's an enormous amount of variation in total alkalinity across this region, both in terms of sort of the mean alkalinity at a particular sampling station. There were sampling stations that had very high total alkalinity, sampling stations that had very low total alkalinity across this entire region. In addition, at each individual sampling station, the variability was also quite heterogeneous around this region. Some stations did not vary much at all in total alkalinity, and some sampling stations varied enormously over a tidal cycle, really just hammering home the need to understand the drivers of the underlying carbon chemistry at much smaller spatial scales and even at the watershed scale. You can see that even some neighboring sampling stations varied enormously from each other. So the second question that we wanted to assess was, can we predict total alkalinity from salinity and develop proxy relationships? So this graphic that you're looking at here is showing you salinity on the x-axis and total alkalinity on the y-axis here for all of our sampling data. And the line here is just this best fit line. And across all of the data available, the answer to this question is not well. We can't predict total alkalinity from salinity very well. This had a very high error, and I don't think anyone would think that these data could be used as, or this relationship could be used as a proxy relationship for total alkalinity with any high degree of confidence. However, there were a number of sampling stations that had variability in total alkalinity that perhaps wasn't driven by low alkalinity fresh water, mixing between low alkalinity fresh water and seawater. And so for example, I've now excluded those sampling stations that, for example, had very high total alkalinity, even as salinity approached 0 over a tidal cycle, or also sampling stations that had very high variability in total alkalinity over a tidal cycle, but very low variability in salinity. And so those are now shown in those open dots that are excluded from this best fit line. And if we exclude those stations, we do get an improvement in this relationship and reduced error somewhat, but the error is still quite high. And again, I don't know if this would be really an acceptable proxy relationship for any high degree of confidence in predicting the carbon system from salinity from these data. However, if we further subset the data, you can see now I've colored all of these dots by sort of subsetting the data by region. And so the blue is representing sort of the northern Maine coast from Casco Bay north. The orange dots are sort of southern Maine through Massachusetts and Cape Cod Bay. The yellow dots are showing you sort of Buzzards Bay, Vineyard Sound, Nantucket Sound, and the islands. Purple here is showing you Narragansett Bay, and green is showing you Long Island Sound. The solid lines are showing you statistically significant best fit lines. The dashed lines are also those best fit lines, but they were not statistically significant. And subsetting the data to smaller spatial scales does improve the fit for many of these regions. We were able to reduce that error to 48 micromole per kilogram. But again, that's still a high error. Each of these regions, although we have a very large data set here, each of these regions doesn't have that much data in it. And so we really felt as though more data were needed to be able to develop these proxy relationships well. It was interesting that these individual subregions do have distinct slopes and zero salinity intercepts, suggesting that perhaps the freshwater inputs to this region varies from north to south. So why are these relationships not as good as we might have hoped or have expected? Well, it actually turned out that salinity was more difficult than we had anticipated to measure accurately. We had monitoring organizations collected salinity measurements in the field using instrumentation that was available to them. And on a subset of those samples, we also measured salinity in the lab on a lab salinometer. And in some of those cases, they agreed well, but in other cases, they differed from the field measurements by up to 7 PSU, which represented a pretty large difference in what those measurements. And that could absolutely have led to increased variability here if salinity was not as accurately measured as we expected. Furthermore, it also might suggest some potential changes to sampling protocols that we could do to improve our predictive capacity. Of course, watershed scale processes may differ even within specific subregions, reflecting the need to perhaps develop these proxy relationships at the individual watershed scale. And of course, biogeochemical processes are happening here too, and that would not necessarily be reflected in the salinity-alkalinity relationship, but might represent deviations from that relationship, and of course could also lead to additional variability. And as I mentioned before, we feel really strongly that although this is quite a large data set and across this region, individual embayments or individual sampling stations really don't have that much data, especially at the smaller spatial scales. And we really feel that in order to develop these proxy relationships well, we would need more measurements to be taken over perhaps multiple tidal cycles and additional sampling events, more than just a single day snapshot. But what can we do with this single day snapshot sampling? One thing that we would argue could be done with this type of a sampling event is that this distributed sampling approach might be able to identify possibly vulnerable locations to acidification that might warrant further additional study. And so this graphic is showing you the mean alkalinity on the x-axis at each sampling station, and the standard deviation over a tidal cycle on the y-axis for each of the sampling stations. And so each of these data points is either filled or open. The open data points represent sampling stations that have been identified as having shellfish nearby. The closed dots are illustrating stations that did not have shellfish nearby. And so shellfish, sort of this designation of nearby, was determined through 3 methods. We asked the folks who actually collected the samples to identify whether or not there were wild shellfish populations or aquaculture operations located near their sampling stations. We also looked at a spatial data layer from NROC on aquaculture operations across this region. And we looked at a suitable shellfish habitat data layer as well from NROC, and identified all of the sampling stations using these 3 methods that were within 1 kilometer of the either aquaculture operations or suitable shellfish habitat. On the same graphic, you'll see there's a horizontal line and a vertical line, and these represent extremes within the shell day data set itself. Although there are not sort of alkalinity thresholds that have been identified to assess vulnerability to vulnerability of shellfish, we can look sort of within the distribution of these data to see what places might be vulnerable or what places are located at sort of extremes in this data set. And so the horizontal line represents sort of the 80% of threshold in the data set for the variability, tidal variability and total alkalinity. And the vertical line represents the 20% threshold for the mean, tidal mean. And so stations that you see below, sort of that fall in these three quadrants here, either have low mean alkalinity relative to the rest of the shell day data set. They have high variability in total alkalinity over a tidal cycle relative to the shell day data set, or they have both low mean and high variability. And we would argue that perhaps these locations without additional information on other carbon system parameters might be places that could be possibly vulnerable to acidification, future acidification, or perhaps might harbor resilient shellfish populations that could be incorporated into shellfish broodstock. But certainly identifying areas that would warrant additional study and more detailed assessment of vulnerability. So there were, just to plug a couple of manuscripts that came out of this shell day sampling event. We published sort of a summary of the data and interpretation of the data that were collected on shell day in environmental research letters. So I'd encourage you to take a look at that manuscript if you can. And then also all of the community engagement efforts building up to shell day, including the shell day sampling event itself, as well as an assessment of sort of the success and perceptions about shell day are going to be published in an invited manuscript in the Coastal Management Journal that we're expecting to come out in May of this year. So stay tuned for that as well. So just to summarize, from the shell day sampling event, we have a number of lessons that we learned and recommendations that are both important to consider for short-term efforts as well as long-term. In the short term, we learned that community science groups are absolutely capable of collecting samples and organizing their staff and volunteers to help with future research efforts that we would argue could have climate level uncertainty of the data confidence. We learned that predicting total alkalinity from salinity may need to occur at much smaller spatial scales than the Northeast region, and perhaps even at the embayment spatial scale. Although we also found that 10 sampling stations that we collected data from displayed variability in total alkalinity that was probably not driven by low salinity and low alkalinity freshwater, reflecting perhaps those places may not be able to develop proxy relationships between TA and salinity. And finally, salinity was more challenging than we had originally anticipated to measure accurately. We've also identified some long-term improvements and long-term sort of expansions, potential expansions of shell day. So one major expansion, of course, could include an additional carbonate system parameter. This would require some modifications to our sampling protocol, as well as some additional perhaps instrumentation to help facilitate sampling with minimal gas exchange, as well as some challenges associated with fixing samples on short timescales to ensure that there's no additional biological activity that happens within those samples. We also identified that, although shell day itself was designed to pilot a sampling protocol, as well as assess some very basic science goals, future efforts such as this could be developed with more process-based questions in mind that might include perhaps longer time series sampling events and longer collaborations with individual water monitoring organizations, or higher spatial variability, looking at smaller scales but more spatial coverage, say within a particular embayment or a region. We also identified, places that might warrant detailed investigations that could occur at sites potentially identified as vulnerable to future acidification. And I'm going to hand it back to Parker to finish up the rest of this webinar.
Thanks, Jenny. So for the NECAN community, we engaged in this in the training series that led to shell day as a way to meet and get to know the community science programs within our region and to understand, what potential there was for coordinated monitoring and how people could get involved. How could we build that capacity around the OA measurements that are taking place in our region. And we found that this proof of concept work around shell day really feels like a springboard for a number of other activities going into the future. That shell day-like activities, they complement OA action plans. And for example, a number of states in our region are in various stages of expanding monitoring for the carbonate system. We're interested in coordinating a shell day-like event with the NOAA OA research cruises, specifically the ECOA 2022 cruise that's coming up. And shell day maybe has potential for other regions. For us, at least, it did a lot of capacity building. We were able to inventory what activities are taking place. We were able to get new partners involved, and the campaign itself overall was an enormous step in public education. Being able to work with new programs and have the time to really dive into the nuances of what drives coastal acidification and how does it differ from open ocean to ocean acidification, and what does this mean for a water quality monitoring program or an environmental stewardship organization that's really thinking about taking care of their individual embayment or their coastline. So for all those reasons, shell day was really functional for us and feels like a springboard to a next layer of engagement down the road. Would you go to the next slide? And so if these kinds of activities feel interesting to you, we've made the assumption that a number of the people on today's call are outside of the NECAN region. But if this kind of work is of interest to you, the training series that led up to our initial engagement with community science programs, the Shell Day event itself and how it brought together students and local stewardship organizations and water quality monitoring programs, the data that we got from this enormous blitz monitoring event, if that kind of work interests you, we actually have a number of resources from our pilot project, which we think can help you leapfrog and kind of get a head start if you were interested in implementing something similar to Shell Day elsewhere or in the future. So on the next slide, probably the premier resource is that we worked with our Region 1 Environmental Protection Agency to develop a full quality assurance project plan for our data and how we would conduct the sampling. And there's a lot of research on the importance of having really rigorous data control and standards for the value of community science, and especially if you anticipate using long-term community science data for any kind of decision-making process. So it was really important for us to work formally with EPA to know that the data that we collected through this project would be as credible as possible. And so that's a resource now that is available to be tailored to a new region or adapted over time. Jennie mentioned some improvements to the sampling design that we'd like to incorporate when we do this type of approach again. And now we get to rest on an existing quality assurance project plan that really helps us take this project to the next level. And this is on the NECAN website. You're most welcome to check it out and use any of the content that's listed on this. And we also have a number of outreach materials and found that communicating about ocean acidification is complex, and it was really important for us to frame these topics in a local context and orient the potential participants in the Shell Day program towards why the work that they are doing now really is so insightful to ocean acidification research throughout the region and how they can anticipate participating in OA research over the long term. So we created a number of communication tools that help us reach a large audience, but also have that kind of local context and local framing. And we additionally put out a series of, we had our data sheets and our sampling protocols. Again, all of these resources are in PDF form on the NECAN website, and we would be so thrilled to have others use them. We feel like the 2 years of planning Shell Day really prepared a foundation of experience and the physical resources for us to make this type of activity a lot easier in the future. We kind of feel like we've done a lot of the hard work to make shell day events possible, and now the sky is the limit. So again, these are on the NECAN website as well. And we also have included a series of webinars and training tutorials that we gave as a way to prepare the monitoring organizations to participate in shell day. And there's, of the videos that are posted on the NECAN website, there's kind of a blend of those webinars that talk about ocean and coastal acidification as an informational and educational resource. And then we have videos that are more about a specific sampling method and a step-by-step series of instructions to make sure that everyone felt comfortable participating and met that quality standard. So the next slide. So our conclusions overall from this project, as Jenny mentioned earlier, we provided evidence that this crowdsourced sampling design is a viable strategy for OCA research. We were really impressed with the quality of data we had, and very interesting to look at a number of scientific hypotheses around the shell day data set. For us, it was the first synoptic assessment of total alkalinity at a regional scale. And that, that alone felt like a big accomplishment for broadening the relevance of ocean acidification to new audiences that have a history of local water stewardship. And from a perspective of outreach and education, we had hundreds of people involved in monitoring directly, hands-on on the shell day event, out in the field, participating in community science. We also reached thousands of people through a plurality of communication approaches. So we distributed surveys at the end of the project that asked how many of the newsletters that we wrote were then distributed out to community science audiences. Again, how many of the social media posts were shared, how many people did the community science programs themselves end up talking with about the shell day activity. And those numbers added up to more than 10,000 people had some exposure to the research initiatives of the Shell Day project. This was across our research team, our organizational partners, and the community science programs themselves. And we also found that engagement with Shell Day prompted existing programs to now purchase ocean acidification specific equipment, and in several instances begin an OA monitoring program as a component of existing activities. So the theory of capacity building was really evidenced by a number of programs starting to say, we want to measure OA, and how can we make it work for our volunteer program or our program that samples in the summer and fall. And we really immediately expanded the interest in OA monitoring. And previous to Shell Day, only about 50% of the programs had considered how the parameters they currently measure related to ocean acidification in the first place. So I felt like this was a big step for broadening interest in OA monitoring. And then also the level of cross-scale collaboration in this project was really exciting. We had the NOAA Ocean Acidification Program involved. EPA was enormously supportive. We had state agency participation across the entirety of the region, and multiple university laboratories, and of course, 59 community science programs, or 59 partners overall, and many, many community science programs and large volunteer audiences. So for us, this was a great way to be expanding our potential in terms of the science research questions that we could ask, but also broadening our community of those who care about and prioritize ocean acidification. So we eager to hear questions from you, and we want to thank our collaborators. We had 59 programs involved in the 2019 Shell Day event itself, and a number of others involved in the training series that led up to it. Our direct collaborators and our project kind of steering committee contributing countless hours at multiple phases of the work over multiple years. We could not have done it without such amazing guidance and participation. And then to the many programs that were most directly involved in making this work happen, and the laboratories themselves that did a really amazing lift to measure the total alkalinity of these samples collected across Long Island Sound to down East Maine. So with that, we will open up to question and discussions. And I'll first ask Jenny, would you like to add anything to those closing comments?
Thanks, Parker, for asking. No, the only thing I just wanted to say was that, we are, as Parker mentioned, we are incredibly grateful to all of those who were involved. And certainly, although Parker and I are sharing with you all today about Shell Day, none of this could have happened without the rest of the team. And, we are very grateful to all of their help and contribution to this project as well.
Awesome. Thank you, Parker. Thank you, Jenny. That was a great presentation. So we have a couple of questions that have come in. One has been semi-answered already, but I'd like to go over it again just to point it out. Somebody asked, will we be able to get a list of participants? So you just showed that list of all the different organizations and the laboratories and all that stuff, all these people that participated. And I'd also like to point people to the NECAN website for the page for Shell Day, which is necan.org/Shell Day, and that list also lives there as well, if you wanted to check that out. The next question is, I'm interested in the areas that were identified as potentially vulnerable, but already have shellfish, especially those that have low TA overall. Did those sites have anything in common that might allow shellfish to occur even though TA was low?
Well, I'll start off and then I'll pass it over to Jenny here. So it's a really interesting question, and I would say that we have not yet done that level of investigation at those specific sites beyond the conversation that that is a really unique circumstance, and there is more and more research about the concept of oases, of OA oases, and areas where shellfish populations might be inherently genetically resilient to OA. And so, at the behind the scenes level of our exploration of this data set, we were also quite interested in what those locations might show, ultimately leading to our recommendation that this is an exemplar location for further study. But we haven't yet answered what those patterns are among those sites that share a property of shellfish are living and thriving in those areas, and yet they show conditions that are historically thought of as being more vulnerable to OA. But Jenny, would you add to that thought?
No, I think you summarized that perfectly. Thanks, Parker.
Great. Okay, so the next one is more just a comment. It's from Dwight Gledhill from the OAP. So he says, great presentation. It seems that there's a need to understand each station in context of the relative end members between the Gulf of Maine and its unique freshwater source. We certainly have a pretty excellent estimate of the Gulf of Maine alkalinity based on ship data. The USGS has a repository of stream data that might be tapped to obtain the unique end members of the freshwater source. If you assessed how the regional freshwater end member changes based largely on underlying geology and or land use, you might be able to derive a numerical approach to better understand this data in terms of its hydrologic context.
So
Any comments from either of you on that?
Yeah, I'd like to start off with a comment here about that. And thanks, Dwight, for that really wonderful comment. And I agree 100% with that assessment. So in the manuscript that's been published in ERL, there is, in the supplement, there's actually a map. We did do exactly that. So we mined the USGS database for stream and freshwater alkalinity, as well as a couple of other data sources as well that have been put together, sort of global river chemistry databases. to look at exactly that question. And so you can actually see there is quite a lot of variation from north to south in riverine freshwater total alkalinity. One of the reasons why we did not do that in this assessment was that we don't necessarily have individual watershed mapping that's been done for all of the places that samples were collected on shell day. And we felt as though in order to really do that assessment well, we would really need individual watersheds and to look at samples that were collected within each of the individual watersheds to do that assessment. But I agree 100% that that is perhaps low-hanging fruit in terms of further analysis that could be done. That was, you know, an analysis that we would have liked to have done, but was beyond the scope of what we had sort of time and effort for this initial data analysis. The other thing that I'd also like to mention too is that the shell day data set is freely available. So it's been published on Quasi, the database, and you can find a link to that in the ERL manuscript as well. And so if anyone is interested in doing further assessments of the data that were collected, the data is freely available. Parker, would you like to add any other comments to that?
Just to echo that, the shell day data set is really fantastic and an interesting window into this oceanographic phenomenon, and we ultimately felt like we were just scratching the surface for the number of questions that could be tackled within this data set. And we really do welcome others to interact with that data and start to explore you know, other ideas within this. You know, a regional snapshot is a pretty unique look at processes that are so dynamic.
All right, thanks, Parker and Jenny. That's actually that's the last question that has come in. We can give people another couple of seconds if they want to submit another question for either Parker or Jenny about shell day and its possibilities, or we'll be ending a little bit early.
So I'd like to prompt the audience a little bit. We have had our fingers crossed that there are some members of the audience that are from other coastal acidification networks, and really excited to share our insight about this project and what we would have done differently. So, you know, we really welcome groups from outside of the NECAN region to reach out and learn more about this work and maybe explore how it could fit in a different area. And, you know, feel free to put into the chat if you're working in another coastal acidification network location and how you think this may or may not work for your region.
That's a really good question, Parker. And I would like to also add to that, remind everybody that this webinar is being recorded. And so if people from other CANs were not able to join this, or if anybody here wants to share this with them, this recording will be made available this week and can be shared widely. And I definitely encourage people to do that. It's going to be on the NECAN website and through the NERACUS YouTube page. So I highly encourage everybody to be sharing this with other networks and with people in other regions as well. And they can also contact us if they have any questions about any part of this. But we do have a question from somebody. They want to know if we're planning another shell day.
Jenny, do you want to start on that? Sure, I can start here. So I am aware that one of the lab and regional coordination groups in Connecticut, based in Connecticut, is interested in planning a shell day, perhaps for 2021. I am not sure that there are other efforts that are planned currently. However, as Parker mentioned, there is the ECOA 2022 cruise, and I think that there would perhaps be quite a lot of interest in planning a shell day, not in 2022, maybe in coordination with that ECOA cruise as well. I think that there's a lot of interest in an additional, in continuing the sort of annual shell day efforts. This has certainly been plugged by a number of sort of high-profile events. For example, the Massachusetts Special Legislative Commission on Ocean Acidification report highlighted our work on Shell Day, and I think if it's not too forward, I would think that the rest of the Shell Day team would love to see additional Shell Days happen in the future. They're a challenge to coordinate as well as process the large number of samples that come in. So there are issues, logistical and financial issues that need to be solved in order to continue this effort going forward. But I think there would be a lot of momentum and interest in future events as well. Parker, did you want to add anything there?
That's great. I would just add that this work for NECAN was really exploratory, and having learned over a series of years about the kinds of engagement that are possible, the kind of data that can be collected, we think that Shell Day as an approach doesn't have to be the only form, and in some cases we kind of anticipate that individual states might organize this kind of approach, might build capacity and build partnerships between community science programs and environmental agencies that are conducting water quality assessments and starting to look at ocean acidification more formally. So maybe the Shell Day model is something that becomes tailored for an individual state's method of building capacity for OA monitoring and research. Alternatively, these kinds of regional assessments were really exciting to get a unique window at such a large spatial scale. And maybe for an event like the NOAA ECOA cruise, the East Coast Coastal Ocean Acidification cruise, maybe there's a way to stagger those nearshore measurements so that they are most reflective of the offshore measurements being taken through the NOAA research cruise. And instead of a simultaneous single day event, you have something that is more responsive to other research that is being conducted. Or alternatively, there are specific seasonal or event-based environmental phenomenon that we might want to really investigate more. What does ocean acidification look like during the first major snow melts in the spring, or during a spawning season for a vulnerable shellfish population? And how could this kind of crowdsourced, in a way, sampling design be useful for checking in on specific ecological events or periods of time? So for us, Shell Day was that open door to think about the possibilities, and we really look forward to future iterations that adapt this kind of way of collaborating with all the partners who may be able to participate in OA research, adapting that to local needs and specific decisions that are to be made.
Okay, so the next question, somebody asked if we could share the link to your paper, Jenny, which I did. I shared that in the chat to everybody in the audience, so I hope you can see that there. I'll also be including links to this paper on the NECAN website, the page for this webinar series. So check for that there. And as Jenny said earlier, Jenny and Parker mentioned earlier, the other paper will be available in May. So once that link is available, I'll share that as well to the NECAN community. And as of right now, that again is our last question. So we do have a couple more minutes if anybody wants to submit another one. I'll just give you another minute for that.
And just to echo Jenny's comments earlier, we suspect, I can't see the attendees list right now, but we suspect that a number of the Shell Day collaborators are on the call, and we just want to thank you again so very much. It took an awesome community to make this work happen, and we so value your time and effort and your insight and all the fun that was brought to this project. It was really exciting to work with everyone on this.
I'd like to reiterate that. This webinar made me excited about Shell Day all over again, and I was definitely highly involved in the planning. Well, that was, so that's the last question officially. So any other closing remarks, Jenny or Parker?
You know, in closing, I guess I just wanted to thank everybody here for participating as well, and for joining us to hear about Shell Day. You know, we were incredibly excited about the data that were collected, the sort of capacity building that was done as part of this, and sort of all of the excitement that was generated around Shell Day. And so, you know, thank you for hearing about it from us, and for joining us here today, and for your excitement to learn about this effort.